Hi guys, welcome to this new video, Area Under the Curve Introductory Lesson. So this is the first part of Area Under the Curve. In this lesson, we are going to see how the geometrical shapes can help us to understand the concept of area under the curve using integration. So as you know, integration of any function actually is another function, like if I take small fx and it is capital Fx plus c, which was in indefinite integral. And in differentiation, the purpose was to get the gradient of the function at certain point x equals to a, b, whatever it is. But in integration, we have seen the purpose of integrating some functions is basically finding the sum of the rectangles or small polygons under that curve but above the x-axis, because it has two parts, fx and dx. Dx is the width and fx is the height, you can say. So that's the area. We can understand this concept using rectangles and triangles. So I have a rectangle, you can see it's 13 units of width and height is 9 units. And as we know from our middle school, the area is 13 times 9, 117 square units. And if we see the concept of integration, if I integrate y equals to 9, because the top line is y equals to 9 because it's a horizontal line, so it should not be just any variable, so it's just a constant 9, and the integration is 9x plus c. But for c, we have started from a equals to 0. That's my original value, like the origin. That's why I don't need to consider my c, so I will just say it's 9x. And what is x here? Actually, x is the width, so the width is 13 units. So if I multiply 9 times 13, I get 117. That's the same area as we have done in the rectangle. Now let's see in case of triangle. So you know the triangle area is half of rectangle. So because we have divided into two parts, so the diagonal is y equals to mx, and area of triangle is half base times height, as we know. So in this case, we can say half times 13 is the base and 9 is the height, and it's 117 over 2 square units. Now if we figure out the equation of line, it's always mx because it's passing through 0 0, so there's no y-intercept. So I can say y equals to mx is my straight line, okay? And the equation can be written as y equals to mx plus b. B is 0, of course, and the slope, the gradient is 9 over 13. And now you integrate this function 9 over 13x. 9 over 13x integration, you know 9 over 13 is constant, and integration of x is x square over 2, and then we have a limit from 0 to 13. So you don't need to put c here, so just plug in the limit values of x, because x starts from 0 and going till 13. So if you simplify that, 9 over 13, 13 square over 2, which would be same as 9 times 13 over 2, which is 117 over 2. So both ways, like a geometrical concept of area and the integration, the result of integration after substituting the limits, the results are same. We can see in this second triangle, this is 0.5x, the diagonal line, and we can see the width is 10 and the height is 5, so it's 5 over 10, that's basically 0.5. The area is 25 square units because of half of the rectangle. And if you integrate this, 0.5 times x dx, so x square over 2, again the constant 0.5 is there, and then you substitute the limits because it is starting from 0 to 10, so we can consider from 0 to 10, and then if you substitute these values, so 10 square is 100, 100 over 250 times 0.5 is 25 square units. So we have seen this in case. Now we summarize this actually. So area of rectangle and triangle are connected with integrals as how? So 0 to width, the integration limits, k times x is the integration, and when you apply the limits, so k times x, k is the constant value which was given by the height of the rectangle, the width is given by the x values. So if the width is 3 and the horizontal line is 5, so we can say the rectangle is 15 square units. That's very basic, and we have done with the help of integration here. Now in case of triangle, the line can be y equals to kx, because the diagonal line, of course it may be different if it doesn't pass through the origin, but first case I have taken from the origin 0 0, and then you integrate and apply the limits. That's what you get the result, k times x1 square over 2. You can see from the example 0.54 square over 2, so it's 4 square units. And we can verify these things actually, like you can draw these shapes and then integrate the line with respect to x, substitute the values, so definitely we can make the connection here. So see, that's very easy. Now we will make this connection. You can see here, if you have 8, the rectangle, and then you divide by that. So basically now if we have a triangle which is not from 0 0, so it's a big triangle, and then if I take away the area 1, which is a small triangle, then I will have my required area. So the whole triangle from like the point O to B to C, okay, that will be my original triangle from 0 0. But if I remove the first part, I'll get my required area. So from 0 to 12, and 0.5 is the diagonal line, the equation of line actually. So triangle OBC, the line is 0.5x, and the limits are from 0 to 12, and the area is 36 units, which is very clear actually, because the x values are from 12 and the height is 6, 72, 12 times 6, 72 over 2 is 36. Now area 1 is the small triangle, and the small triangle equation won't change, only limits will change from 0 to 5. So it's 36 minus 6.25, 29.75 square units. That would be the required area. We can verify this in different ways. So let's take one more example where the slope is not 0.5. So we have y equals to 4 times x, and of course it is passing through 0 0, and we are looking for the required area. So we can say the area under the line but above the x-axis from 1a to 1, like a to b. So if you integrate the function, which is like capital Fx, if I write, and then you substitute the limits. First you plug in the b, which is the upper part, okay, and then f of a, because f of b will give you the area from 0 to b, and then you subtract the first part from 0 to a. That will be the required area from a to b. We have one example here. So 4 times x square over 2, very basic, from 1 to 3. So remember, first you substitute the upper limit, which is the always bigger than the smaller value. So 3 square is 9, 9 times 2 is 18, minus 1 square is 1 actually, so 2 times 1, so it's 16. Let's verify this actually. So you can see the triangle is from 0 to 3, and the height is 4 times 3 is 12 basically. So 3 and 12 is that point B. So the height is 12, so 12 times 3 is 36. And if you remove the first part from the rectangle, if you do the triangle, then you divide by 2. So for the triangle, it's actually the small triangle, the width is 1 and the height is 4, which is 18 minus 2, and it's 16. Verified. So we will use integration for calculating area under the curve from point A to point B. We will integrate first and then substitute the limits. First upper limit, then the lower limit, and you get the result. So we can have more examples. Maybe you can verify with your calculators or other things. For example, here I have a trigonometric function 2 sine 0.5x plus 5, and that's the required area. So if I ask you what would be the area, so you can simply say integration from 5 to 15, because that's the limit from first part to second part of the function, and you plug in the limits after integrating. That would be the required area. I'm just writing this in case you don't need to calculate here, but you can use calculator, but otherwise you can plug the values one by one. That would be the area. I have a last example for you, which is I have calculated its area, and let's verify with integration. I'm going to plug the values here. So this actually equation is it's a inverted variable, so negative x square minus 3x, and we can write it actually negative times x squared plus 3x. The limits are from negative 3 to 0. So if we integrate this function from minus 3 to 0, that would be the required area. So negative 3 to 0, that's the lower limit. Remember, the lower part is the smaller value. You can say negative 3 is smaller than 0. So negative 3 to 0, x squared plus 3x, you can put negative outside. You integrate it, you just use power rule, x cubed over 3 plus 3 times x squared over 2. Apply the limits, negative 3 to 0. Don't forget to write minus because it was negative already. Now you first plug the 0, you will get 0, then minus because we are subtracting. So 3 square is 27 times 3, 3 square is 29, 327. The negative 3 square is actually 9 times 3, 27 over 2. So we can calculate this area, simplify this. It should be 4.5 actually if you simplify, and just take care of negative signs. So negative 9 plus 13.5, which is 4.5, and it's verified because this one is calculated from GeoGebra, 4.5 square units. Practice and wait for the new video.